Alrighty, guys. We're now doing another Unraid video. This one's going to be regarding AI. I've been wanting to get into the AI stuff for Unraid for a minute now, but I've been waiting for a good time, and now is definitely a good time with the Deepseek, excitement going on. So as you'll see, I already have a few things here, and that's just because I just spent the last like 10 hours trying to get it to work because nothing's ever as simple as it would seem. So remember, the goal is to get Deepseek, the Deepseek model on our Unraid. So what we're going to use is we're going to leverage Ollama. Now, one of the things that Ollama doesn't tell you when you're going to install Ollama, all right, we'll go ahead and just navigate it, assuming you don't have it, right? So let's go ahead and jump into apps. Go ahead and jump into the AI category. You can search it too, but we're already right here. Boom. And then right here at the bottom, we have Ollama and Open Web UI, right? So Open Web UI doesn't tell you this, so you wouldn't see it, right? But if I was to go here and try to install it, okay, this is all of the default stuff. This is not going to work. By itself, it is not going to work. What you need is you're going to install it, but what you need to install first is you have to install Ollama, right? It took me quite a long time to realize that was the very first main problem I was dealing with. So you're going to install Ollama, and then you'll install Open Web UI. Now, there's going to be some extra configurations you're going to need, okay, which is why I didn't delete these so I could actually show you. But let me start with Ollama, since Ollama is the first one you're going to install. So first and foremost, Ollama, there is nothing to change. This is just about how it comes defaulted, with the exception of just like me changing where I put my Docker images, my Docker containers at. But all of this is unchanged, untouched. Okay, nothing here has been edited. So you should be able to just install that straight, and then you're good. And then the way you'll know it works is if you sit here and you go to your Unraid, whatever's the URL for your Unraid, right? Colon, and you do 11434. You should get a little like text that says Ollama is running. That means that we're good. We're in the business. Now for Ollama Web UI, okay, here's where it gets really complicated. Make sure you have advanced view set. All right, so let's start from top to down. So first and foremost, this is whatever is here, I think it's called main, is fine if you're not going to use GPUs. If you're going to use GPUs, you are going to have CUDA. All right, you're going to need to select the CUDA version. So make sure you're using that if you're going to use the GPUs. Okay, and I was just scrolling down. Next, let's talk about the port number. So that's why I'm going to come down here. Okay, you need to check and make sure that you don't already have a container that's using the default port. The default port is 8080. If you do have a container that's showing up saying that it is using port 8080, then you need to change it. And it is not easy to change it on here. There's like 3 different things you got to change. So first and foremost, under advanced view, you're going to go here to Web UI. You need to change this to, whatever port you want to pick. In my case, I did 81. Then you're going to come down here, right? And then this is actually going to say Ollama IP, right? You either put your IP address or host names. Remember I say in all my videos, guys, host names go a long way, right? Host name, but you just put your host name or IP address and you can leave that as is, right? You don't need to worry about that, okay? It's going to be this, oh gosh, where is it? Oh, yeah, that's right. All right. You're going to see, now it's not going to be down here, but like, the default web UI, you're going to need to edit this. When you edit it, your container port, for whatever strange reason, right, is going to be uneditable. I don't know if it was just a bug or maybe it's because maybe I was like trying to edit it while I was running or something. I don't know. I just remember that when I tried to edit the default web UI, right, I could change this, but for whatever reason, I could not change the container port, and that's going to be a huge problem, okay, because it's going to be 8080 and it's not going to let you change it. You will, and as you can see, like if I wanted to change it now, I couldn't do it. What you would have to do is you need to remove it and then recreate it. So you just come here, do port, you can call it web UI, right? Call it web UI and then give it the proper port numbers that you're going to use. Okay, make sure it's TCP. All right, that's how you get that. Now you're still not done, right? After after you do the web UI, then you need to make another variable, right? And you have to give it another variable, and it has to be called all uppercase port, and then you give it the same port number, right? Because otherwise what's going to end up happening is, for whatever reason, and you won't notice it unless you go into the logs, you might even be able to get to the web UI without a problem. For whatever reason on the back end, there's like a service that's still going to run on 8080 unless the port variable is 8081. That's what I was dealing with. Okay, so you need to actually do that. So make sure you make an additional variable called port and you give it 8081. All right. Now, last very thing is GPU is going to be the GPU thing, right? And this is based off of their documentation. Just make sure you make another variable. The key is GPUs, right? So GPUs, and then the value is all. And then that's it. That's what you need to set up. And then you'll hit, you hit done, apply right, let it download the CUDA image. There's a big boy, so it might take a minute or so, but you'll do that, and then boom, you should be able to then get into your web UI. When you get into your web UI, it's going to ask you, to create your your username, right? Make sure you do it correctly, because if you don't, you need to nuke the folder, wherever the config folder is. You need to nuke it, because it's only going to ask you for the information one time. And so if you fat finger it and then press enter like quickly, right, obviously then it's going to be wrong. But you go into web UI, right? Well, after you give the account and you sign in, then you agree to here. And you're like, okay, yay, cool, right? So here we are. What you're gonna need to do is you're gonna go to settings. You're going to go to admin settings right here. Then you're gonna go to connections. If you don't use the OpenAI, there should be a default OpenAI thing here. I deleted it. What you just do is you just go to config, right, and then you hit delete for the OpenAI one. But then here, right? So then here, this should be, I think, like localhost or maybe something like that. Again, it might work like that, but I just, once again, right, gave it my my Unraid URL, right? So the host name to the server, and then I did 141, the 11434, excuse me, right? And then you could verify the connection. This should say server connection verified. That's how you know you're good. If you won't get to that point, right, then you need to you got to figure out where your connections went wrong, right? Which I just showed you everything to possibly make it right. I didn't need to change nothing, no network host or anything like that. I was able to leave it bridged, no extra flags, right? And in fact, let me just double check so that we're not crazy, because like I said, they don't really do a good job letting you know. Yeah, see, I don't have no post arguments or anything extra. So, all right. So then we're gonna come here to manage, right? And then boom. Now here we go. We are able to now start pulling models. So what I'm going to do is, so then you can, if you go to ollama.com and then you just search for the model, you can do Deepseek, right? Because that's the one we're interested in for all of the cool hype. And so what I'm going to do is we'll do Deepseek R1 : and then we'll start doing each one of these and see kind of how they rock. So let's start with the 1.5B. So the way that's going to work is I'm going to, let me just grab this here, right? We're going to go to the admin panel. Let me close that extra tag here, or extra tab, right? Deepseek R1 : 1.5B is how it should work, I believe. And let us hit download, and let's see, pulling manifest. And sure enough, right, and it should be really quickly. What I'm going to do is I'm going to go ahead and I want to download all of them. So I'm going to go ahead, I'm going to do 1.5, and I'm going to do it all the way up to 671, or maybe I'll stop at 70, because I know dang sure my system's not going to do 671. Now, as just a quick thing, right? So the main model is this one, the 671 billion parameter. Obviously, you're not going to have a system that's going to be able to run that, but you might be able to run these other ones. These other ones are what's called the distilled models. Okay, so they're not like, so the distilled models aren't like a separate like set of models from these, right? These are the distilled models, and then this is the main model, right? Which, if you got a system that can actually run this, more power to you. But I have all the ones I'm going to try, because I'm going to try 1.5 up to 32. I just finished downloading the 32. That's why it is not there. So I just have to refresh, right? Connections, And if I go here, look at the models, and boom, right? Yep, see, they're all right there. I'm going to see if they will work. Well, I'm gonna see if my system will allow it to work. And just as a quick recap, as far as like what I'm rocking, right? So I have three NVIDIA RTX 3060s and then a Intel Xeon E5 2680, right? Which is just a 2.4 gigahertz processor with like 26 cores. Yeah, 26 cores, and then however many threads, right? Then so let's get back now. So now that we're here, so let's go ahead and let's jump back to new chat. All right. And so first thing we're going to do is I'm going to want to do 1.5. And what I'm also going to want to do is let's pull up we're going to need to pull up a couple of things so I can just see how it works. So I'm curious what the log will show me once I like give it um, a prompt, and then I wonder how the rest of my systems will do. So let me say, how can I help you today? How are you doing? And let me send that, and then let's come back over here to our server, see what it's doing. Okay, yeah, so it most certainly is using some GPU off the bat. Nothing crazy. I mean, there's only a 1.5. Oh, okay, that was probably really faster than I didn't see. So all right, let's kick it up. Well, let's do it one more time so I can just see how fast it is. So let's see, that was 1.5 just today. Let's say, can you give me? Okay, so can you give me an example of things you can help me with? Let's see what we got here. And yeah, that was pretty fast. Wow. Okay, that's 1.5, right? So let's now jump to what's the next one, right? The 7. We got 7, 8, 14, and 32. So let's go ahead and just go to 7. All right, we're loading up the 7. All right, let's see. So what do you say? Sure, if you ask a question about something, I'll provide helpful answers. For instance, if you want to know how to solve a problem or learn something new, feel free. Okay. Give me something new to learn. Okay, and then I just want to make sure I have my this up. So let's see. So this isn't gonna actually tell me much, but it's loading up the 1.7. Let's see what we got here. RAM usage is minuscule, right? Because it's a Docker image. I see it moved over to like one of the other GPUs, but I was to say it was still thinking. Thought for a few seconds. Okay, here we go. So yeah, let's explore a exciting new area, artificial intelligence, and then it gives me all these good things. Okay, cool, 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 cool. Right, and let me just delete that tab so I don't get confused no more. Okay, well that was pretty cool. Let's see. So looks like it's using a decent amount GPU memory over here, a little bit over here, a little dab over here, but not really. Okay. All right, let's do one more test here. Let me know if you'd like a deeper dive into any specific aspect. Um, sure, let's ask them about quantum AI. Okay, so let's do quantum AI. Tell me about quantum AI. Okay, let's see. So it's sitting there and it's thinking, what's this do? All right, so I'm trying to understand. Oh, cool. So it's actually thinking. That's pretty robustly fast there. And what is it doing? Looks like it's rolling pretty good. Like I said, again, my RAM usage, these are Docker images. My RAM usage is from the Docker images. It's not really touching anything. So all the work is definitely on the GPU for sure. And thought for 15 seconds. Wow, man, this is actually crazy. Okay. Um, So I feel like the 8 is going to just be just as fine. So let's jump to 14. Well, this is cool, right? So at least with the system we got, so it looks like at least with the CUDA thing, definitely leveraging the GPUs. The 3060s are a godsend in today's like state of the market. If you could find, because you could find them for good prices, like $300 under and under. If you get really lucky, like maybe around 200. Um, like I said, hardly any touch on the RAM. See, I didn't really see anything much on the CPUs, and I got slow CPUs, so all the work is really just the GPUs, and it's yeah, the fact that it's got all of this going on in the background, so like the tokens is pumping out is crazy, but we just knocked it up to the 14 billion. So let's see how we're doing here. So in summary, quantum. Okay, so this was all the other stuff. So let's say, um, do you think, what is it? Yeah, quantum, right? All right. Do you think quantum AI will be able to run solely on quantum chips, or will GPUs still matter? All right, and let me fix my. All right. Do you think quantum AI will be able to run solely on quantum chips, or will GPUs still matter? And now we're on the 14 billion perimeter. All right, so that's jumping. Let's see what we got here. Again, CPUs not really seeing much work, but the or CPUs not seeing much work. GPUs, just one really doing quite a bit of the work there. Okay, so this is definitely maybe a touch slower at 14. Um, mostly using just one. Again, right? RAM untouched. Um, okay, so here we go. I got the final answer. Man, this is really cool. So let's see. All right. So I'm trying to wrap my head around this question. Do you think we'll be able to run solely on quantum chips? Okay, let's break this down. First, I need to understand what kind of AI is. From what I know, AI generally refers to artificial intelligence. Oh my gosh. This is like literally going through a step-by-step thinking process. This is crazy. My God, bro. This Deepseek stuff is awesome. Okay. You know what's crazy is that I'm still getting pretty decent performance. Like I'm not really noticing anything crazy, uh yeah, I'm not really noticing anything crazy with that regard. So let's see now. All right, well, we're gonna go for the big board now. Let's go 32. I really wonder how I was gonna handle 32. Let's see, response tokens per second. So it's doing 24 tokens a second. Sheesh, prompt tokens. I might have to download this. I might actually have to download the 70 billion one. That's crazy. Prompt tokens. Oh, sorry. It's response tokens, just a slash s for plural. Had me go. I was like, oh my God, it's doing 24 tokens a second. That's amazing. No, that's not. Definitely, I definitely misread that. But approximate total 52 seconds. So 52 seconds to do all that. Okay. Let us, in conclusion, quantum AI will likely complement GPU-based systems rather than replace them entirely, with both technologies potentially working together in hybrid systems to advance AI applications. Okay. Okay, so the next response, the next response I say, okay, but don't you think that without some significant advancements, that quantum chips may surpass GPUs to a point where they become where the CPUs, where the GPUs, right, where the GPUs become bottlenecks, right? Let's try that now. This is now the 32-bit. We're gonna do two prompts for this one because I want to see what it look like in person, and then we'll jump to our thing over here. All right, so let's see. So, okay, definitely significantly slower. Um, using two. I know I was gonna look, but I think because I think it's just trying to just load the model to begin with. 32. I mean, it's 32 billion parameters, so um, it's definitely doing both of them. Okay, see, so it's finally loaded it up, so it's doing it. I feel like this is slower than the other ones, although I can't really tell. So, but if I'm looking over here, it's only using two now of my 3060 GPUs, right? One's at 33%, the other one's at 60. So it's not even 100%, so still not even maxing them out. I forgot, I didn't even realize my GPU 3 was on 16 lane and the other one's on 8. But okay. Let us all right, my mouse died. So that was definitely exciting. And let's see. So on the 32-bit, thought for a minute. So one full minute. So just a minute. That's not bad. Like I'm trying to tell you guys, that's not bad. For a 32, I'm actually gonna have to go back now and download the 72 billion. And I might even go this. I seriously thought I'm gonna be able to do the 671, but wow, I'm actually gonna have to download. Let's go download it. This is crazy. As a matter of fact, can't I do it here too? I sure can. Uh, let's do. Can I just search right here for? Okay, well, I guess I'll just type it. Let me see what it look like when I need to download it from here. Deepseek -R1 colon. I believe it's 70, right? Because we did 32. So the next one is 70 bill, right? Just a quick note too, guys. I said a few videos ago, I did the OpenWart dashboard where I showed how to get the OpenWart metrics up onto your Grafana, the cloud one, which of course, you got a local instance that'll work too. But the reason why I'm bringing this up is because, interestingly enough, as you know, like obviously like the Ollama, right, is on my server. And I would have thought that when you're downloading these models or stuff, right, that this is being done on the server, but it looks like some of this stuff is being done through the computer, but not necessarily. So this router in particular is my downstream router, right? So my server is connected directly to my upstream router. So my downstream router should not have been reporting this much data pool, and yet it was. So that's just something to keep in mind, because and the reason why I even dawned on me to even look at this is because crazy enough, when I sat there and started pulling like multiple models, this video recording kept crashing. And for the life of me, I couldn't understand, right? Because I'm so my OBS is streaming to a different server, so it's not even the server with that that all this is even run off of. Is running to a different server that's on the upstream router, and it just seemed like I was getting serious bottlenecks and crashing. But just keep that in mind. Very strange experience. But I guess it's somehow leveraging your system to do like some work, I suppose. But we're done, right? We're done downloading the 170 billion token. Now let's see if our computer gets set on fire, and if we're satisfied with the results, I guess I will try and do the 671 version, and we'll have to go from there. Let me just pull back up the Ollama. Yeah, 671, right? So all right, so let's see what else are we going to tell it now. All right, so here's my prompt now. Don't you think it's a little unfair to compare quantum chips in their current state with GPUs in their highly matured state? The issues you point out with quantum chips, like high error rates and expenses, are valid, but wouldn't that have been the same with the earliest stages of CPU chips? It wasn't that long in history we found out that gamma rays from space could flip data on the system if it hit in a super rare way to do so. So assuming we had the reliability and expense of get that extra of quantum chips on power GPUs. Is their design and capabilities enough to say they could outperform GPUs? And this is important, right? Because gamma rays in outer space do flip data, and that's why we do a lot of things. Shielding. This is actually why aircraft, right? So aircraft are especially designed for that situation. If I recall correctly, I think I remember reading a story where before that was the case, there was times where like there was an airplane that kept nosediving because it kept getting hit with a gamma ray or you know, whatever it is. It might not be gamma rays, but whatever it is in space, whatever is the type of laser in space, what type of radiation in space that sat there and screw with the electronics and make them do really weird things. So this is the 70 billion token or 7 billion parameter one, right? So let's see what happens. So let's go ahead, hit send. It's going to have to load that model. So let's see. Whoa, man, it is rocking all my well, not all, but like over half, right? I want to say that's definitely half. So that's all of one CPU. Anything on the RAM? I mean, 2 gigs. Okay, cool. And they're no longer so none of them are throttling. Okay, so only one of them was 33%. So it looks like this is just the loading phase. And then it jumped to like the other half of my my CPUs here. So this is interesting. Is it okay? Yeah, so it's most certainly still loading. Let's see what we got here. So this is the 32 billion parameter. And it looked like I guess it looked like it's like distributing the work is what it seems like it's doing. Oh man, look at that. Yeah, see. Yeah, look, it is yeah, nothing on the RAM. So I guess RAM is like completely, I was just like really worried about the RAM thing because I was reading about a lot of systems, but I guess RAM is just really not really a worry. Let's jump. So still loading, right? So we're going to do 2 messages, right? Because I know the very first thing it has to do is going to load the model, and then we'll give another prompt and then see if that's like way faster. I expected the very first one to be particularly slow. What I find really interesting though is just the fact that this is the 70 billion. So the 32 billion. So that means the 32 billion was relatively fast. I don't even know if we even like tried a second message just to see while it was still loaded. But yeah, our system is definitely screaming. And remember, this is a you know, slow CPU chips, right? 240 gigahertz or Intel Xeons, old Xeons. So yeah, this is I'll go ahead and I'll pause this right now and I'll come back once it's starting to make some movement. Oh snap, it's actually like doing something. Crazy thing is you can look at the time. I don't even know how much time elapsed. It's definitely a significant amount of time. I went and like cleaned up the dishes. I brushed my teeth. I was about to get in the shower because I was getting ready to go to sleep. And here we are, right? It's rolling it. And so let's see. But yeah, incredibly slow, right? So it's finally fully loaded it, and it looked like it's doing a token like every 2 seconds, I want to say. It looks like so let's see what we got over here. So yeah, so it's definitely using a lot more CPU. Or maybe it might have just swapped over completely the CPUs. Like, yeah, which is really weird because I don't see, again, right? This is a Docker container. They're both Docker containers. I don't see much RAM being like utilized for this, and this seems so deceiving to me. Oh well, there we go. Well, I mean, I see we jumped up on the GPU, but it's like for a slight moment. I don't get it. I actually really don't get it. Let me jump into the advanced section real fast. I'm just trying to see what Ollama is yeah, well yeah, right. So definitely using the CPU cores, and 64 out of 61 out of 94 gigs. Oh, so is that just a dash? Oh, okay. So this whole time my dashboard was lying to me. It had to. Okay, so the whole time my dashboard was lying to me. That's why. because this is telling me 61 gigs of RAM that it's using. But here on the dashboard, I don't know why it. Yeah, here on the dashboard is lying saying it's only doing 2.26. We'll have to figure that out another time. Might have to report that. Yeah, might have to report that. Okay, well, let me pause this real quick here. And remember, guys, whenever you can pinch in to, like, report bugs and stuff, you should do it. I had to grab those screenshots because I'm definitely jumping in the Unraid forums about that because this whole time I'm thinking I thought it was confusing me. I was like, maybe it's somehow loading it all into the VRAM of the the GPUs or something, but silly me. All right, so okay, well, this looks like we're approaching the end here, and it's still thinking. So this was what? Is it gonna tell me what time? Do I get to know like what time? No, I don't. I don't remember what time I had like this, but because I don't know if this was like when it started thinking or when it actually loaded up finally to start thinking. So 1:40 in the morning. It's 2 o'clock now, so we're talking about 20 minutes to get this response, right? You think we should try the 671? Thought for 10 minutes. Yeah, 10 minutes and just thinking alone. And then here it goes, starting to plot the answers. Oh, and then another thing too is as far as RAM speeds, now that I know it's actually doing RAM. So I have 95 gigs of RAM, but I want to say it's 2000, the 266, the 266 speeds, I think. I don't even remember where you'd even go on here to even look and find out. But yeah, it's definitely not like I'm not sporting like the 3,200 megahertz or the 5,000 megahertz, right, or nothing like crazy like that. This is literally like the slow. I think, as a matter of fact, I think it's the 2333. Now that I think about it, the 2,333 333 megahertz RAM speeds. So maybe that might help it a little bit. I mean, I technically I got a lot more cores. It could have put the work, or maybe that's its limit for how much it can do. But we see that if for whatever reason you really needed to do the 170, you can get it to work. You see, I got it to work. You just need, again, I don't even know if the GPUs are really being used, but on this hardware, which is really cheap, like it's a dual Xeon, right? So this is 2 Xeons here. Okay. And like with this motherboard, I got this motherboard, the motherboard CPU RAM combo for like, I think around $400. Now this is pre tariffs, but it says some deals out there. So if you're able to come across, some cheaper hardware, you can definitely get it to work. And it looks like the only like main thing you just need is you're just gonna need some sufficient RAM. So I think at best, like the most I've seen people rock at home is like 32 gigs, right? And so right here, like out the gate, right, we're at 61. So you are most certainly, you're most certainly looking at more than 64 gigs of RAM you need to have in there, right? Because if you put in 64 gigs worth of RAM, as you're not really getting all 64. I think it's like a couple of gigs down from that. Is it? Yeah, still going. But yeah. This is, it works. So thinking back at the 671, if the 32, what is this? I'm sorry, 70, right? Yeah. If the 70 would use 641 gigs, then yeah, the 671 would probably needs like, I would guess around 500 gigs of RAM would be my guess. Yeah, and it'd probably be terribly slow like this. 10 minutes just a little. Well, and the thing is, this isn't like crazy slow. Like again, if I was really needing this, the 70 billion model, right? I could, this this will be okay enough. If it's going to give me, if it at least gives me a really good answer, got to give me a really good answer to justify these speeds. But if I could get the 671 working at this speed, that would be an incredible achievement. And I want to say, definitely 500 gigs of RAM, probably. And I would like to say probably approaching, I'm sorry, I went to the wrong one here. I would probably say approaching 3.8 gigahertz. Right? I want to say, yeah, I want to, definitely at least, well, you probably don't even need necessarily this many cores, but it looks like what? We're looking at, probably like 12 cores. I'd say like 12 cores and each one having a thread on them. So, 12 cores, if you get like maybe 12 cores, 3.4 gigahertz at least with 500 gigs of RAM, it maybe you might be able to get up to this with the 671 billion model. Maybe. I don't know. That's just my guess. But remember, the initial load time would probably be astronomical. So just keep that in mind. But it's working. I'm gonna go shower and I'll be right back. Okay. We're gonna see how this, how long it takes for this to like fully finish. All right. So it looks like I wish I knew exactly like when it completed. Maybe there probably is like something maybe in the logs or something. Approximate total time 44 minutes, so almost an hour to make that response, which obviously is not ideal. But like I said, I want to say like that was just the initial hurdle of having a model loaded up, which, as I think about it, I wonder if the Docker thing is still using up a lot of the RAM. I want to say it's still loaded up for sure. I believe that's how it works. I could be totally wrong. Yeah, see, it's still 60 gigs. If I'm not mistaken, but I think it does have like a certain time limit before I think it does dump it out of RAM. I could be totally wrong in that I read something else. But like I said, this is all new to me. I have not messed with Ollama at all before, besides just like the pre stuff I had to do to get it working for this video. Because like I say, as you guys probably seen in all my videos, most of my videos, I'm actually recording it on the fly. So like I didn't do it before, and I just like, I'm recording, pausing so I can just like take a moment to look ahead and see. But yeah, it's working. And just to take a look at this, like how Deepseek does it, right? It's thinking. It says, all right, let's try to unpack this. The user is comparing the current state of quantum chips to GPUs, which have been around for a long time and are highly optimized. They're pointing out that early CPUs had issues like being affected by gamma rays, which seems a bit random, but I guess they're saying that all technologies have their initial problems. Bro, the inference, excuse me, bro, the craziness on like how like these models like are thinking is just crazy. Like even like down here where it says also the user mentioned something about gamma rays affect the early CPUs, which seems like a metaphor for how initial technological flaws can be overcome with better design and engineering. Like this is all the AI. This is how the AI was thinking about what I asked it, and then it produced like the answers. This is amazing. I will say this is amazing. And with that being said, right, this is the end of the video. So this was a real quick way. It was actually honestly not too hard. None of this is ever too hard, just as long as you know is the proper way to set it up, because that's always the problem, right? Nobody ever has the proper like full 100% way to show you how to set something up and it worked right out the gate for a lot of these things, right? Like, so if you install Ollama, the Ollama WebUI, or which is, actually called the open WebUI. I don't even remember where it's at anymore. Yeah, the open WebUI, right? You have to install Ollama, which I didn't know, right? You have to install Ollama. Nothing to change in there, but in that, there's a whole host of things to change. A lot more if you already have like some other Docker containers that are using port 8080, and then like those little quirks, I'll say, with the Ollama, with having to like basically like change the port like 3 different ways in order to make sure it stick for me. Like, all that was crazy. And then, but the GPU stuff all works pretty fine, making sure you use the right tag so you can use it, right? All of that is great. So with that being said, that actually wraps up this video. Hopefully it was helpful to you guys. It's for the ones that were having challenges getting it up and running like I was. It's nice to see that I can pull a 70 billion parameter, model in my cheapo hardware, right? Because my hardware is nothing all that great, at least in my opinion. Okay, especially at 2.4 gigahertz and speeds, since it was sure using a lot of CPU to do what it needed to do. But yeah. Oh, and then by the way, just as a real quick note too, I was right, because I was like, before I even shut it down, I was just gonna just give it one more like quick prompt, and this actually loaded up much faster. I noticed it says it's like 239 is 253, but I want to say like what this was like well, it was like 140 and it was already like 2 o'clock or 2:10 or something like that, right? So this one, like, it literally like took like 10 minutes, like 10-15 minutes before like it started pumping out a response. So yeah, so I was right. Like, once it's loaded up, once the model's loaded up, then everything else is much faster from that point on. So just keep it in mind, right? So I'll likely be using the 32 billion model going forward, but that's just nice to know that even at that initial slow experience I had, I'll be much faster after the first prompt. So I'll just check and see like what's the total time on this compared to the last one, and then we'll wrap up. All right, and the final time for like that second run through was 27 minutes and 22 seconds. So yeah, so like I said, right, after you run it the first time, it'll be significantly fast, like I guess like half that speed. At that point, I'm trying to see, okay, so remember like the first one, because this was when we was using the 70 billion token, right? And look, see, we got 44 minutes, so almost 45 minutes, and this one did it right in about half that time at roughly 27 minutes. So yeah, so just wanted to just show that real quick before I jumped off, that indeed, that after you load it the first time, right, it's much faster. So, and that's if you got a system that can handle 70 billion, then you're golden, right? But the 32 should be just fine. And the nice thing is that after that initial slow loading and using of the 32 billion, like subsequent prompts should be much faster and quicker. So that's it. Now we're ending the video. Take care, guys.